1.9, solving equations and inequalities graphically. This section has to do with solving by graphing, and it talks a lot about using a graphing calculator. So if you have a graphing calculator, bring it to class, and we're going to look at pages 104 to 107 for some examples. So in solving problems, there's the algebraic method and a graphical method. The algebraic method uses the rules of algebra to isolate the unknown x on one side of the equation and get the constants on the other. So for example, we have 2x equals 6 minus x. We want the x on one side, they will be positive on the left. So we get 3x equals 6. We now know to divide by 3 to isolate x, and x equals 2. The graphical method tells us to move all terms to one side and set the equation equal to y, and then sketch the graph to find the value of x for y equals 0. Okay, so we need everything on one side, so let's just move the 2x, because it's only one term. We bring down the 6 minus 3x equals, and now it says set it equal to y. Let's put that in slope-intercept form. Y equals negative 3x plus 6. So now we are to graph it. And see where what the x value is, where y equals 0, which is on the x-axis. So we're at positive 6, down 3, right 1, down 3, right 1. So we see that we are crossing the x-axis at 2. For a quadratic that's unfactorable, we can use the quadratic formula. So this is the algebraic. We have a to be 1, b is negative 4, c is 2. Plug it into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we can change negative 4 to 4 plus or minus square root of 16 minus 8 over 2. This all simplifies down. X equals 4 plus or minus root 8 over 2. Root 8 we break down. X equals 4 plus or minus 2 root 2 over 2. And we see this is even, this is even, this is even. We can take out a 2 from each term. This goes to 1, this goes to 1, this goes to 2. So our answer is x equals 2 plus or minus root 2. Okay, if we were to do this graphically, we could just plug it into the graphing calculator and find the x-intercepts. If you had to do this by hand, you'd find the x value of the vertex, negative b over 2a. This goes to 4 over 2, which is 1. Plug in 1 for... that goes to 2. Plug in 2 for x to find y. 2 squared minus 4 times 2 plus 2. 2 squared is 4 minus 8 plus 2. So this is negative 2. So our vertex is as 2, negative 2. Insert a graph. So we're at 2, negative 2, up 1 over 1, 3 over 1. So we see that it doesn't cross directly on a point, and it correlates to x is approximately 0.6 and 3.4, which is what you would get if you worked out 2 plus minus root 2. When you're asked to solve an equation in a given interval, such as x cubed minus 6x squared plus 9x equals root x, in the interval from 1 to 6, you really need a graphing calculator to do this precisely. So, first step that you would do is get the equation set equal to 0. So you would have to subtract root x from both sides. And we know root x is 1/2, so it's going to go at the end because of order of degree. So we get x cubed minus 6x squared plus 9x minus root x equals 0. You would type this equation into your graph, and you would set the window so the x scale is 5 to negative 5. So this would be the max, and this would be the min. And the y scale is going to go from 1 to 6. This would be the min, this would be the max. Nope, that's totally switched. This should be the y scale, and this should be the x. Sorry, I don't have my graphing calculator in front of me. So your graph will be produced. And it will look something like this. And then you can use your tools on your graphing calculator to find the zeros. And we'll see that x comes out to be 2.8 and 3.72.